Sorry, it was mute. Very good morning to all of you. Very good morning. Very good morning. Am I audible? Voice clear? Crystal clear? Now it's fine. ठीक है. So today I'll start. See, yeah, battery. Fine. ठीक है. Today I'll start the basic portion of organic chemistry. Yeah, Divya ma'am took periodic classification, yes. Very good morning to all of you. Very good morning. So Divya ma'am took the inorganic portion periodic classification. That is completed, right? Very good. So today I will start with the basic portion of organic chemistry. Mainly we are focusing on IUPAC nomenclature. ठीक है. Yeah, I'm Taufeeq. My name is Taufeeq Ahmed, Mohammad Taufeeq Ahmed. I'm teaching the organic portion, basic organic portion to you people. ठीक है. So shall we start? बोलो. So already somewhat you have an idea. ठीक है ना? Basic organic means we are mainly talking about the carbon, and then we'll discuss about the IUPAC nomenclature. So in organic chemistry, if you have any doubts, you can related to the topic, you can directly ask. Otherwise, hold on for some time. At the end also, you can ask those questions. Fine. Mandeep and Dharmana will discuss about these things later on. They are not relevant right now. Okay. So my point is, carbon shows tetravalency. Means carbon can form how many bonds? 4 bonds in total. है ना? Maximum 4 bonds. In detail, orbitals involved, that is not the part here, because always we should do whatever is most relevant. Whatever is most relevant, we should do it first. So we should know that what is the part we should leave. Like hybridization is there. Maybe you people don't know, most of the students. Hybridization part we are not considering now. Only we are focusing on IUPAC. Before IUPAC, some basic terminologies. Okay? When you start with the syllabus normally, then you will cover the in sequence hybridization also. So better is right now only focus on the basic portion, and then we jump onto the IUPAC nomenclature. So most common example, which you all relate easily, because in class 10th also you have done basic organic. CH4, carbon is tetravalent. 4 bonds it can form. Carbon with 4 hydrogens, right? And carbon can form long chains. That is the term which is, you can relate easily. That is a property which is termed as catenation. Due to this property, the property which is known as catenation, due to this property which is catenation, carbon can form long chains. That chains which are having strong bonds. And that is why we talk separately a portion which is termed as organic chemistry, means the chemistry of carbon, hydrogen, and some other elements may also be present. In organic chemistry, it is the chemistry of carbon, hydrogen, and some other elements may also be present, like nitrogen, oxygen, sulfur, phosphorus, halogens, these may be present. So we will deal, because of the numerous compounds formed by the carbon, we take separately a branch which is termed as organic chemistry. Take now, why carbon forms millions of or so many compounds? Because of a property that is catenation. Catenation means a self-linking property or self-linkage property of carbon. Self-linkage or self-linking property of carbon. Why it shows catenation? It involves some terms like overlapping of the orbitals, strong bonds. So that's why catenation, if you remember, it's good. Detailing we will not do here. Why catenation is shown by the carbon? If you know, it's very good. Otherwise, I will say orbitals are involved, strong bonds. Maybe some of you will not be comfortable. So our target is that we have to go for the nomenclature, right? And before nomenclature, some basic terminology. Catenation is a self-linking property of carbon. Like carbon can form strong bonds with itself and with other elements. In this case, carbon, carbon, carbon. Yes, carbon is bonded with each other. This is carbon, other carbon, other carbon. So catenation means a self-linking property of carbon. It is a self-linking property of carbon. Why it arises, I will say, but do not write anything about why it arises. This portion we will discuss in detail when actual syllabus will start. Okay? So self-linking property of carbon is termed as catenation. Basic example, it is propane, 3 carbon, ethane, or carbon can form long chains. Why it form long chains? Due to the property termed as catenation. In detail, catenation, no need to write right now. Understand this term, it is a self-linkage property. Getting it? So in organic portion, organic chemistry, it is a chemistry of carbon, hydrogen, and some other elements may also be present. Okay, in class 10th, you have done basic nomenclature. Yes, basic nomenclature you have read also somewhat. You have the idea, somewhat idea, not detailed, somewhat idea. Am I right? Because it's a part of class 10th syllabus, carbon chemistry or carbon and its compounds. Yeah, so do you have the idea, little bit idea? So after the class, just read it. After the class, just read it line by line. Okay? You have the book available, am I right? Book availability is there. Whichever book you have, class 10th book. Even if it is deleted, no worry. The point is that portion will be in 11th also in detail. That portion will be in 11th in detail. Okay, so by this time, what we are discussing, basic meaning. Organic chemistry means chemistry of carbon, hydrogen, and some other elements may also be present, like oxygen, nitrogen, sulfur, phosphorus, halogens. Getting it? Basic terminology, listen carefully. The point is, these classes you can make the maximum use, because in detail we will cover everything in the syllabus, but these classes will make you connected to the subject, that yes, connectivity is still there, right? And main thing is, after the class, be more systematic. Whatever you are writing in the class, you have to write systematically. After the class, revise it also. Which portion you can read from class 11th syllabus, I'll say that portion. If you want, I'll say these paragraphs you should read. Basic paragraphs, no detail, you don't have to worry much. But the point is, be consistent, be organized. Whatever you do in a systematic way, the output or the result is extremely good. And that is your target. You want to be selected, you are preparing for NEET exams. It's very good, but be more organized so that in one shot, you can clear the exam. Yeah, everything will be as per NCERT syllabus, not beyond that. That is not required. That's why I said at the beginning, you should know what you don't have to read. A lot of students, they sometimes get distracted by the so much content given. But you have to realize what is most relevant, what is least relevant as per the syllabus. Take. So this just now what we are discussing, organic chemistry. And what is the meaning of catenation, which is a self-linkage property of carbon? Carbon combines with itself or with other elements and form long carbon chains. This is termed as self-linkage property of carbon. And that is the meaning of catenation. Take now. You want to write the definition or you know this part? Organic chemistry, meaning and everything. After the class, you have to read your 10th class book. That's why I'm saying this is basic term. You will get directly, but still read it line by line. So you want to write the meaning. Already I have said 3-4 times, but still if you want. Okay. If you want to write, then properly make a notebook, separately mention this. What is the meaning of organic chemistry? The chemistry of carbon, hydrogen. It is the chemistry of carbon, and some other elements may also be present, like oxygen, sulfur, nitrogen, halogens, etc. That is the general meaning of organic chemistry. The chemistry of carbon, hydrogen, and some other elements may also be present. Examples I will give depending upon the topics we are covering. Yeah, alcohol, yes, it contains oxygen. Aldehyde, it contains oxygen. Okay. Then why carbon forms numerous compounds? Why? Due to which property? Due to the property of self-linkage property that is termed as catenation. The catenation is a self-linkage property of carbon. You want to write, you can write, but prepare separate notes then. Maintain the notebook after the class, read it, and after reading notes, read the NCERT or your class 10th book, line by line you have to read. Make this habit, be more systematic, be more planned. That is a very crucial point at the beginning. Return that portion. Then in one line mention, catenation means it is the self-linkage property of carbon, by which what will happen? It will combine with itself long carbon chains are formed that are stable also. These compounds are stable also, due to which property they are combining? Catenation. I will tell which part from the NCERT you can read right now. Just listen carefully, write it down wherever required. ठीक है? Written? Okay, fine. Now, next term is the structural formula. Okay, now in the yes, you can write in the same book, no problem. You can leave 2 or 3 pages, whatever Divya ma'am told, you can write in that same, because actual content, detailed content you will do in the regular classes. Okay, but whatever you're writing, write it separately. After 2 or 3 pages, you can start writing the organic chemistry portion, basic portion up to IUPAC. So structural formula, when we know the molecular formula like C2H6, ethane, we can write its structural form. So structural formula basically reveals the bonds or connectivity of the different atoms. So structural formula can be expanded form. Expanded structural formula. Structural formula means you are showing the structure of the molecule by representation of different covalent bonds. It can be represented as expanded form, condensed structural formula, and bond line structural formula or bond line notation. Structural formula, we can write the structure either in the expanded form or condensed structural formula or bond line notation or bond line structural formula. Okay, so starting with the first one, structural formula. Started with the first one in the expanded form. Expanded structural formula. Again, basic example. Which one? One carbon with hydrogens, which is methane. It is its molecular formula. Methane is CH4. One carbon, how many hydrogens? 4. Because carbon is tetravalent, maximum it can form 4 bonds. So you can represent it in this manner. It is which form? It is which form? Expanded form. Each bond we have to show. Each bond we have to show in the expanded form. That is the meaning of expanded structural formula. So it's a basic example. Next, if I write C2H6. So with each carbon, how many bonds we will form? 4. 2 carbons are bonded. Okay, 1 bond between them. Remaining we will put hydrogens. This is 1, 2, 3. 1, 2, 3. This is which form? Expanded form. C2H6. This is C2H6. Getting these 2 examples. This is the expanded form where each bond we have to mention properly. Take next example. Molecular formula. its expanded form. How many carbons together? 3. And each will be bonded to other carbon as well as hydrogens. Carbon A is tetravalent, each carbon forming 4 bonds. Terminal will be always CH3 here. Then CH2. Then now tell, is this clear? Carbon tetravalent. We are representing the structure. In structure, first one is expanded form. ठीक. Now C3H8 हो गया. Next example, if I give C2H4. C2H4 tetravalent beta means 4 bonds it can form. Carbon can form 4 bonds. That's why it is considered as tetravalent. Yes, carbon if forming bond, neutral molecule, it has 4 bonds. C2H4 ethene molecule. Carbon-carbon double bond, it is alkene. And remaining valency is completed with hydrogen. This is which one? Expanded form. In C3H6, propene molecule. Any side you can write double bond. It is which form? Expanded form. Each bond is shown properly. Take. But when you read now, you will get example of alkanes only. I'm writing alkanes because some of you have read, so they ask the question like this. So that's why I'm writing these examples. But whenever you read it now, you generally get saturated examples, no multiple bonds. This is alkene. Alkene means carbon-carbon double bond. Alkyne means carbon-carbon triple bond. Now, if you want to write butane molecule, which one? Butane, C4H10. Try to write. I am writing butane. So before I write these examples, this is saturated. Yes, this is alkene example. C2H4 alkene, in which carbon-carbon double bond is there. If you do not understand right now, just write it. When you will cover other portion, then you will understand alkanes, alkenes, and alkynes are there. Maybe in class 10th you have skipped that portion. That's why it is finding little bit odd, but write as it is. Focus will be on saturated means all carbon single bonds, no double bonds, no triple bonds. Write down for C5H10. Similarly for C5H12, one such possibility. Alkynes, right now, I think better is not to do it. We can do, I'll tell that one, but if you have read some word, then it is better. Hai na? There are possibilities. Charged molecule is there. It is not molecule, actually, it becomes ion. If carbon has charge, like carbanion, carbocations are there, that are there, but these are not molecules, they are termed as ions. How many carbons? 4. Then how many hydrogens? Total 10. CH3, CH2, because each carbon can form 4 bonds. Terminal will be CH3. Here terminal also CH3, and middle will be CH2, CH2. Try for C5H12. I am writing one possibility only. Which possibility? Straight chain. Not even writing branching. Basic example so that you can relate easily. Slowly, slowly, we will pick it up more examples as we proceed. C5, one such possibility. How many hydrogens we have to place? Total 12, and it is saturated carbon chain, no multiple bonds. CH3, CH2, 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 CH3. Ions are possible. Don't worry, examples will be there, but right now if we do everything here now, it will be messed up. C4H12, no such compound. Why? If you try to write, hydrogens will not match because it is C4, then it should be H10. Why? Alkane formula CnH2n plus 2. Expanded formula clear. Expanded form, mainly alkanes. Mainly alkanes. If you are not getting alkene, no worry. Basic portion. We'll do it. We'll do systematically. ठीक है, चलो आगे बढ़े. Now, after the expanded form, next is condensed form. Condensed structural formula. ठीक है? Like if it is C2H6, this is molecular formula. ठीक है? This is molecular formula. We can write it in condensed form in this manner. CH3, CH3, that is, it is condensed form. Whenever you read the books, you will find such type of structures, not generally expanded form. Okay, and whatever doubts you have, you can keep writing in the side also. Maybe at the end we will discuss those doubts, right? This is ethane. It is molecular formula. It is structural formula. CH3, CH3. If I write it above, already I have written, each bond is shown separately, expanded form. In condensed form, we will combiningly write CH3 and one bond we can show, not all the bonds separately. Other example. C3H8, which structure? It is propane. So how to write CH3, CH2, CH3? Even if you want to write, you can write it like this. CH3, CH2, it is understood each carbon is bonded with 4 bonds are there. Each carbon is tetravalent. Yeah, it is correct. So point is, carbon forms how many bonds? 4 bonds. Take expanded form, each bond has to be shown. So examples are there. You have to read that part again after the class. Do not think it is basic portion. Read it, then you can read further from the whatever class 10th book you have, you can read that portion from there also. ठीक है ये, then we can talk about C5H12, or before C5H12, another example with C4H10. One such way is CH3, CH2, CH2, CH3. How many carbons? 4. CH3, CH2, CH2, CH3. Carbon tetravalent, terminal will be CH3, terminal will be CH3. Other way is, other we can also say, how many times CH2? Twice. ठीक? So other we can write is CH3, CH2 twice CH3. It also means the same, condensed form. How many times? 2 times. Either this one or this one. Both are correct. ठीक है? Another basic example, C5H12. Firstly, you try, then I'll write. Try like this also and try like this also, both. ठीक है, चेक करो आंसर. One such way is it correct? Yes. Otherwise, you can combiningly write them CH2 thrice. So this can be CH3, CH2 thrice, and CH3. That is also condensed form where we are not showing each bond separately. It is a condensed form structure of C5H12. ठीक है. Alkene, alkyne examples generally you do not get for condensed form. That's why only I am writing which ones which are containing only single bonds. Can we write it? Yes, we can write that also. Now, if I give you condensed form, can you write its expanded form, for example? If I give you this is condensed form, can you write its expanded form? So you can write it, this carbon is bonded to CH3. ठीक है, so I can write is this carbon is bonded to CH3. Or I am writing another way of writing the condensed form. Either this is correct or CH3 here. Carbon, how many bonds? 4. One with hydrogen, one with CH3, one with another CH3, and one with another CH3. This is also right condensed form. It is also right condensed form. I can expand it also in this manner. Very good. IUPAC name is 2-methyl propane, but if you do not remember, no need to worry. IUPAC naming we will do. This is also correct. It is also correct. And if you want to write expanded form, this is again correct. It is not butane actually. Naming I will say. No need to do right now naming part. This is CH3, this carbon. How many bonds? 4. One with CH3, one with H. Third bond with another CH3 and fourth bond with another C. Bracket means this carbon is bonded to CH3. Bracket if coming to the right side of the carbon, it means the carbon here is bonded to CH3 also. Take example, this type of example you will also get in the class 11th of the NCERT. Basic examples these are. Now try to write here, chlorine is written. Now this can be, can you understood that one? This one. This carbon, right side bracket, which atom is there? Chlorine. So this carbon is bonded to Cl also. This carbon is bonded to hydrogen also. This carbon is bonded to methyl also. And this carbon bonded to CH2 carbon also. How you can write it in this manner? CH3, CH, Cl. Then further CH2, CH3. You can write the bonds also. This is the meaning of the structure. Yes, Pawan Sheikh, yes, correct it is. Condensed form means we are not showing all the bonds. Only 1 or 2 bonds we can show, but we will not expand the structure. That's why it is a condensed form. Getting it? It is also condensed form. It is also a way of writing in condensed form. Always 4 bonds with carbon. Always 4 bonds. So how many examples we have done? Your priority is basic example, first, second, third, and fourth. Your priority is this one. Then when you read on your own, then you can think about further examples, but write it properly. Even if we write it for glucose, yes, we can write in the same fashion, like this one. I can write it like this: CHO, CHOH, CHOH, CHOH. Yes. But do you get these examples? No. Do you get the example on write down condensed form of glucose? Not relevant. No, we cannot write CH3 twice there. Where? Here, C5H12. Here you can write CH3 twice. Here. There you can say. You can also say here CH3 twice CH3. Or in fact, you can also say CH3 thrice also. Okay? Basic meaning of condense is clear or not? Are you going to get bulky questions on that? Never. The answer is never you will get any bulky questions on the condense. These are only for understanding the meaning of condense or expanded form. Okay, till this point clear, basic examples. Then next is third, bond line representation or bond line notation. But whenever you read it, you have to read up from the class 10th board book also, the basic portion given. Okay? Do not just read the notes and leave it. After reading the notes, you can read the book. Line by line reading is required. And you will get all this portion with few examples. No need to worry, that is only required. Now in bond line notation. In bond line notation, minimum example which I take here is ethane molecule. How many carbons are there? 2. CH3, CH3. So how to write it? How to write it is, we can represent it by a line like this one. This is the meaning of which notation? Bond line notation. Bond line notation means we are representing the carbon chain using the line here. Starting point and ending point, these are considered to be carbons. Starting point and ending point is carbon, or we can say whatever vertexes are there, they all are carbons. Whatever vertexes, they all are carbons. So here, CH3, CH3. This is which point? Starting point. This is carbon. It is understood in which notation? Bond line notation. How many carbons? 2. One is here, bonded to other carbon there. And carbon is which valent? Tetravalent. So this means we have written it like this: C, C, H, 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 CH3 and CH3. That is the meaning of bond line notation. No need to mention carbon and hydrogen. Other elements we can show. Other elements we can show in bond line notation, but carbon is understood starting point, ending point, carbon, and any vertexes are there, which I'll give the examples that are also carbon. And valency will be completed as per the point that carbon is tetravalent. ठीक? First example, basic ethane. Now I'm writing next example, C3H8, which is CH3, CH2, CH3. How many carbons are there? 3. So in bond line, one of the way is starting point, carbon. Second, vertex. Each vertex represents carbon and ending point again carbon. That means what I have written like this, or CH3, CH2, CH3. So in bond line notation, no need to mention any carbon and hydrogen. It is understood each vertex is carbon, starting point is carbon, ending point is carbon. Can we write aldehyde? Yes, we can write aldehyde group also. This portion in detail, whenever we start the nomenclature of functional groups, there I can use directly bond line. No need to write carbon chain again and again. It will save time also. Copy this part. Carbon has to be tetravalent, so valency has to be completed. That's why CH3 at the terminal. In the bond line, we never write any elements. We have to separately show them. Bond line means carbon, hydrogen, no need to mention. It is understood each point here, starting or vertex, they all are carbon. Carbon, carbon. Another carbon, another carbon. Terminal also carbon. ठीक? Carbon is tetravalent. So one carbon is forming bond with other carbon. One bond is formed. How many bonds carbon can form? 4. So one is already formed. Remaining is with hydrogen. So bond line, it is understood whatever valencies are left, they are with hydrogen only. Try to write for this compound, CH3, CH2, CH2, CH3. Write down the bond line notation. I'll write it. Yes, all are we can write expanded form, condensed form, bond line. These are the examples so that whenever you get any example in bond line, you can understood the formula. Structural formula already written, formula of the compound. You can identify it easily. How many carbons? 4. Straight chain written. 1, 2, 3, 4. Starting point, carbon. Each vertex represents carbon. Ending point also carbon. How many carbons? 1, 2, 3, 4. That means what is written? It is written like this. And how valencies will be completed? Valencies will be completed with hydrogen, like one carbon bond, remaining 3 with hydrogen. Here, remaining 2 CH2, remaining 2 CH2, and remaining 3 with hydrogen. Can we write it like this also? Yes. Or you can write anyway. Bond line notation, you can write it like this also. Correct. You can write it like this also. It is also correct. CH2, sorry, CH3, CH2, CH2, CH3. Any of the representation is correct. Starting point, ending point, carbon. Each vertex is carbon. Any way is right. Main thing is, once you understand it, you can write it anyway. Basic point, starting point, ending point, carbon. Vertexes are carbon. Now, if I write bond line notation, can you identify the compound? Identify the formula or identify its structure. Bond line given, try to write its normal carbon chain structure. ठीक है, अब देखो, the students who have done, they can try it. How many carbons? Starting point is carbon. ठीक है, 1 each vertex carbon, 2, 3, 4, 5. So the students who got 5 carbons, they are correct. It is CH3, CH2, CH2, CH2 and CH3. That means the formula is C5H12. It is pentane. Yes, we can write bond line for unsaturated also. But right now, focus on the basic example, saturated. Similarly, try next one. How many carbons? 1. Each vertex is carbon. 2, 3, 4, 5, 6. कितने? 6 carbon. Very good. So it is C6H14. How H14? Try on your own. CH3, CH2, 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 CH3. Till this point, copied. Till this point. Copied or not? Next example is here, this one. CH3 can never come at the middle. Think about it. If you write in the middle, you will not get tetravalent. It becomes pentavalent. I've given you a hint. Think about that. This structure. How many carbons? This is 1 carbon. Second carbon. Third carbon. Fourth carbon and fifth carbon. Very good. So you can write in this manner. It is CH3, carbon, another carbon, then further CH2 and CH3. Total 5. 1, 2, 3, 4, 5. Very good. Yes, good, very good. CH3, CH, CH3, CH2, CH3. Correct it is. Another example you can try. Write the structure. I have written bond line. Remember one thing, bond line notation saves your time. You don't have to write carbon, hydrogen, but you should be able to write all the type of structures as per the questions given. Complete the basic level of questions always. And then you cannot write for everyone. Why to unnecessarily waste time also? Whatever examples covered, solve all of them. ठीक है, try to write the carbon structures involved. ठीक है, I'm writing the answer. Check. Each beginning starting point CH3, CH3, CH carbon here, another carbon, total 6 carbons. I am writing them. Check your answer. Valency can be completed with hydrogens also. CH3, CH3, very good. Here also CH3. Then here hydrogen is present. Here also hydrogen present. Here CH3 and there also CH3. Total 6 carbons are there. That means the molecular formula is C6H12. It is C5H10. H10 near, sorry. C5H12, it is saturated. It is also saturated. So formula will be CnH2n plus 2. Copied. Next also try this one. This is middle carbon. Which one? This is middle carbon. Bonded to individually other 3 carbons. 1, 2, 3, 4. CH3, 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 CH3. Yes, we can write condensed form also. Main thing is you try these questions which are coming in your mind. After the class, when you work now, you have your thinking process will keep on working. Then you can try on your own also. I'll give you which questions you should try. Okay, in NCERT, this question is given, precisely given. ठीक है, check करो answer. Check karo answer, just this one. How many carbons? CH3. This is carbon, another carbon, another carbon. 1, 2, 3. Then each vertex is carbon. Carbon. It is CH2. Then this vertex is also carbon. This is carbon with 2 other carbons. Valency will be completed with hydrogens. Do you get such questions in the exams? No. In NEET, they will give you such examples, not possible. But these are the basic learning portion. Getting it? So that is why whatever examples are given, complete all of them. And then no need to do much extra. It is completed means, yes, it is completed as per the requirement of the syllabus. Everything is completed. But complete them all. Now this example, understand, this example is alkene. So how to write in alkene? We can write it bond line notation. How many carbons? 3. So I can write it like this also. 1, 2, 3. Between carbon, carbon, how many bonds? 2. So we have to show it like this. How many carbons? 3. 1, 2, 3. CH3, singly bonded with other carbon, CH. It is bonded double bond with another carbon, and that is the bond line notation. You can write it like this also. You can write it like this also. All are correct. If that is the structure given, try to write its bond line notation for this compound. Try to write its bond line notation. Completed. Try fast. Do not lie down here and there. Full focus. What is going on in the class? Okay, I'm writing the answer. You can check. How many CH3? 3 here. CH3, CH3, CH3. This intersection point is carbon. Then next is CH2. Next vertex CH2. Ending it with another carbon. This is the correct bond line notation. So important is firstly writing the saturated carbon chain. Up to this point completed. Till this point, if you want to ask any question, you can ask. Very good. Those who are getting it correct, very good. Those who are getting any incorrect, they should again read it. Okay, na? They can ask and then they can read it from NCERT also. I'll tell which page number. Now, next I give you example basic for the alkyne. Yeah, we can write for other angle also. But in alkyne, we have to remember it should be straight line with the triple bond like this. It is the correct representation for alkyne. This is starting point, one carbon. This one. Next, see, this is second carbon, starting point here, where 3 bonds are mentioned. This is here, triple bond started. Then another ending carbon, and that is the correct representation. बोलो, यहां तक आया समझ में? Till this point? Another example if I give is of CH3 C triple bond C CH3. This can be written in the bond line notation. You also write, I'll also write it. Firstly you try, then I'll mention here. In V shape, we cannot write the triple bond. Why? Because point is there that bond angle should be 180. This comes from hybridization. So that point, right now, just write it like this. Hybridization will be done later on. In this case, the structure will be like this. This initial point, carbon. This initial point, also carbon. Taufeeq. And there it is carbon and carbon like this. First carbon CH3, then carbon triple bonded. This is one point here, this is another. 1, 2, 3, and terminal again CH3 carbon 4. That is the correct representation for which one? Above structure, but to wine. IUPAC nomenclature we will do. So bond line notation means what? In bond line notation, we will never write carbon and hydrogen. Other elements which are present, they can be represented here, but not carbon and hydrogen. Expanded form means each bond has to be shown. Expanded means each bond has to be shown. Take. Now ring structure. Benzene, you all remember? Benzene structure. This is benzene. Now tell me, this is which notation actually? Which you see in the books, which you read in the books. It is which notation? It is bond line notation. Getting it? Carbon and hydrogen is never shown. It is understood each vertex is carbon. So if you want to write each carbon, you can write it like this. It is for the understanding only. Each vertex carbon, 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 carbon. कितने carbon? Six carbons are there. And here double bond, there double bond, there double bond. Now tell, this carbon which is at the top, how many bonds formed? 3. How many left? That is satisfied with hydrogen. This is the bond line notation which we get in the books, and this is actually what it is, the carbon skeleton structure. Now if I write without double bonds, cyclohexane, naming if you don't know, we'll do it later on. Naming is not the part right now. Right now we are only focusing on the structure. Can you write its carbon skeleton? This is the each vertex carbon. How many vertexes? 6. Carbon has how many bonds? 2. The remaining 2 bonds will be with hydrogen. That is the actual meaning. That is C6H12. Getting the meaning of bond line notation? Each vertex, yeah, when you practice it now, the whole point is, see, in the class when you are going through, okay, some word you maybe you have some little bit doubt. After the class you have to read it. Then you actually have to thought process will start that yes, that is the meaning which is related with the example. Then I will tell you which page number you should read from NCERT also. It's not like that just attending the class and dancing here and there. You have to work also after the class. Till this point clear? Now one more example with multiple bond I am writing. Try to find out its normal structure. Because carbon is tetravalent, above carbon has 2 bonds with other carbons, so remaining 2 with hydrogen, that's why CH2. Carbon is tetravalent. Now clear? 2 bonds with carbon, other 2 with hydrogens. Total 4 bonds, tetravalent. Now this is bond line notation. Each vertex is carbon, ending point also carbon, initial point also carbon. So firstly I'm marking it, carbon here, carbon there. It is also carbon, it is also carbon, and this is also carbon, which is intersection point for other carbons. So I'm writing the structure, check your answer. Then each carbon tetravalent, 1 bond is formed, remaining 3 with hydrogens. CH3, CH3, CH3 and CH3. That is the actual structure. So when you have good practice, no need to write carbon and hydrogens, directly write bond line notation. Or if bond line notation is given, you should be able to understand it. Identify from this bond line notation normal carbon structure. Try to write. This is ring structure. Each vertex is carbon. So firstly mark the vertexes as carbon here. 1, 2, and 3. 1, 2, 3. Each carbon bonded to one other carbon, two other carbons. So remaining two will be with hydrogen. CH2, CH2, and CH2. If you count the total carbon and hydrogen, formula will be C3H6, but it is a ring structure. Each vertex is carbon and each carbon is bonded with other carbons, two bonds, so other two with hydrogen. Similarly, try for another one, cyclobutane structure. Try to write its carbon structure properly with C and H. No, we can write like this also, correct. But will you get such examples in the books? No, they will directly write the bond line notation. So we should know the meaning of bond line, expanded form, condensed form. Very good. It is cyclobutane. How many vertexes? 1, 2, 3, 4. C4. Each carbon bonded to two other carbons. Remaining two will be with hydrogen. So that is the way it can be written also. Cyclobutane is the naming. Naming part we are not discussing right now. If any one of you have completed it, it's very good. Naming we will start in the next lecture, not today, only focusing on the basic part, which is structural formula. Okay, now I have written one structure. It is bond line notation. Each vertex is carbon. So you check your answer also. I am writing here. Before I write, you should write the answer. Okay, now tell. Carbon here bonded to two other carbons. So remaining two valencies will be with hydrogen. H, H. Another H, another H. Here also, there also, there also, there also. And this is the completed the tetravalency or four bonds of each carbon. So now tell what is the formula. Above C3H6, here it was C4H8 and it is C5H10. Bolo. Till this point, any doubts, any point you want to ask till this point? But the important thing is after the class, you have to read it. After the class, you have to read it. Then page number of NCERT which you should read or your class 10th book which you have, you can read that portion. Naming will be done. Naming we will do. Ring structure is there. That's why. Which example should be repeated? Tell which one. No, no, no. It is not butene. Why? No double bond. It is ring structure, cyclo, but naming part leave right now. Buy NCERT book. Buy NCERT book is very important. Class 11th, buy both part 1 and part 2. Difficult examples you can try. Wait for that. Otherwise, what happen? It will be messed up. These are basic examples. When you read NCERT, you will get the slightly tricky example, but not much difficult examples required. Yeah, carbon is hybridization is deciding the shape of the molecule. ठीक है, the first thing that you should buy NCERT book, right? Part 1, part 2. Yes. Yeah, this will be useful in understanding NCERT. This will be useful in understanding the chapters. These are used directly. In NEET exam, are they going to ask directly a question on bond line, converted to expanded? No such chance. But it is basic portion. Without understanding it, you will not be able to understand the examples given. So you are just starting early. There are a lot of students, those who start late. So you have an advantage. Surely you have an advantage. Try to read. Try to read. Hexane, which structure? NCERT you should buy. NCERT you should buy. Other material will be given. Our material will be given. Hexane has no double bond. Hexane has no double bond. It is merely single bonds between carbon atoms. How many of you have NCERT book? Alkene means carbon-carbon single bond. Carbon-carbon single bonded structure, that is alkanes, carbon and hydrogen. Class 11, two parts, part 1, part 2. Let me check here if it is working here net or not. Did it happen? See the students, firstly your target is you'll take the book, you buy the book. Till that time from the NCERT site you can download it, but never depend upon the soft copy, because when you work you should have the hard copy. You have to mark it, use highlighters wherever you are getting some good points. Class 11th, subject Rasayan Shastra, which is chemistry. Then it's the part 2. It is in part 2. It won't matter. It is 219 model, no matter. Content is same. ठीक है? 11th, which part you have to go through now? Part 2. But you have to buy both parts. Class 11th, both parts you should buy. If for the time being, from the soft copy you can download from the NCERT site, ncert.nic.in, and here it is part 2, class 11th chemistry part 2. ठीक है, from there you can download the part 2. See which chapter you have to go through. Unit number 12. Which unit? 12th unit. Okay. Firstly, if you have that class 10th book, you can read that portion. Then NCERT class 11th part 2. Chapter number 12, organic chemistry, some basic principles and techniques. Where you have to read which part, which page number, I'll tell. Read this portion. Page number 336 from the downloaded book, I am saying. If you have the hard copy, you can quickly check that one. Part 2, some basic organic principles and techniques, chapter number 12, unit 12. And you have to read 336 page. 12.3, structural representation of organic compounds. You have to read this 336, 337, and up to 338. Up to 338 means problem 12.6. That is up to 338, it is going on. Three-dimensional model, no need to do right now. So I have given you a target after the class. You should read it. Where is that file here? Not there. Okay, that file is not there. So homework is, what is the homework? Homework is from the NCERT page 336 to 338. You have to read. Done? Anything you want to ask apart from this? Okay, take care, bye-bye. And any student you want to ask, I'll explain. Hexene structure. Hexene structure, multiple possibilities, but hexene, I'm taking only one possibility here, which is C6H12 with alkene. So one such possibility is 1, 2, 3, 4, 5, 6. And you can write one such possibility. 1, 2, 3, 4, 5, 6. Other possibility, it is also hexene. 1, 2. Naming will be done. That's why I'm saying simple examples understand first, and this is other possibility. Now clear? QR code is not there. That file is not available. It has gone. Maybe it is not saved because I have shown the NCERT book. It is not there. Bolo. So which page number you will read after the reading the class work? 336 to 338, and your class 10th book, whichever you have with you, read it. And regularity is required. Be consistent. Okay. Take care. Bye bye. ठीक है, done. Bye bye. Thank you.